All right, so we have just one slight little change on the board over there. Okay, this part 2 of this exam is in 2 parts. You have a part A and a part B. Okay, so remains to be seen how many problems there are, but if we're not that anybody's struggling in here, but a way to make up ground quickly, okay, is especially over these problems because they count so much. Like if there were 10 problems on your daily work, it was 40 points, 4 points each. Okay, get the answer wrong, it's -2 straight off the top. Your problem quiz, if it was 7 questions, okay, then it was probably worth 45 points because the point value is just a little higher on that short evaluation. Now we got a bigger one where chances are this is close to maybe 80 or 90 points, okay? But that's why it's over 2 days, okay? So we've read that first problem. So what is the best thing that, how many times do you suppose we've said that? What is the best thing that you can do for yourself? You suppose we've done it 8, 9, 10 times saying, what is the best thing that you can do for yourself? Right. So what information do we know from this problem? What do we know?
2.81 miles per second squared is your acceleration.
Okay. That's pretty fast. We know what you mean.
Oh,
Yeah, that's pretty fast, but we know what you mean. Okay. So how do you know it's talking about moving? Okay. So what does that mean to you when you see that label? What specific label is it?
squared acceleration.
So why is it not a velocity? Because of that little number there. Okay, so the acceleration, 2.81 meters per second squared. What else do we know? We know a lot of things, like science is great, school is great. We know that. Cross country is great, volleyball is great, football is great, Minions are great, the Vikings are great, Kirk Cousins is great, periodic table is great. We know a lot of things are great.
McDonald's.
Okay?
Food is great. Of course you say that.
So what else do we know? Why are you right? Because you're correct. See? So we want you to do that though. So the variable for this is told by this. So what is the variable for this number? It's the product, or P equals 8,000. And this tells you that this is measuring what? When it's labeled in this, it's telling you it's measuring what? It's measuring momentum. Okay? So then, what else do we know in this problem? Yep, we got that.
The time is 2.8.
Okay? And that's labeled as what? Okay? And someone said our final variable. That was, okay? Which is what? So up to this point, we haven't tried to decipher what is the question asking.
How fast was it moving?
So when we see this, okay, what is that asking for? Okay, and we have solved one of those before, okay? But when we do this, where do we see velocity in any of our formulas? it's actually found in all three of them. Okay? So this is where you use your intuition here. Okay? So what is one formula where velocity is utilized? Okay? So in our acceleration formula, what is specific about our velocities? Okay, but which one's first? And then owie? I could have swore I heard owie. Trust me, I can go back to the videotape and it probably picked that up on my microphone that whoever said owie. Okay? All right? So what's this over? Okay. Is there another formula that has velocity in it?
Yeah.
What would that be?
P equals V times M.
Okay? And then there's actually one more.
V equals distance length.
Distance over time. Okay? So now, as we look at this, when we're talking about an initial velocity, okay, that means at some point we've got to isolate this variable. So how many variables are in this formula? There's 4. And how many variables do we know? Is that a problem when we use this formula? Yes. You can't have 2 unknowns within this and try to solve this problem. But when we look at this content here, okay, why is utilizing this formula going to help you? You have 2 of the variables. We don't have a distance. We've got a time, but we don't have a velocity. So we can't use this one. And this is what we're trying to solve for. And when we talk about momentum, if it's times a velocity, do you suppose that's an initial velocity or a final velocity when we talk about momentum?
Final.
It's going to have to be a final velocity. So when we talk about momentum, initial velocity has nothing to do with our momentum formula. It's the final velocity that we would use in here. So is this formula going to help us? The answer would be yes. Okay? So how many are on front row? Are we on the bus here? Second row, are we on the bus? Third row, are we on the bus? Is this a confident yes and thumbs up, or is it one where, oh boy, I just wanted to do this so I don't stand out? We're okay? Because if you say that, I understand, that means we keep going. Okay. And whose responsibility is it if you are struggling with this? It's your responsibility. I just evaluate you on what's in front of us. Okay. So what are we going to do with this formula here? Okay, you said divide. You're not wrong, but we got to set this up with our equation. What goes on the left-hand side?
8,000.
Okay. Okay. Then what's on our right-hand side? Okay, once you got it to this step, how do you get V all by itself? Okay? Kind of saying it like divide, like I don't know. Yeah. Sounds like we're saying it like a question. Maybe not. Okay, so divide each side by 840. So now our velocity is what? So these actually cancel, but that's okay. You can divide 800 by 84 if you wanted. You get the same answer. But 8,000 divided by 840. Is it 95 or 9.5? I need to get my spectacles. 9.52. Okay. So specifically, our final velocity is 9.52. Because in this problem, that is how fast this animal was moving when it collided with its prey item. Does it say a seal? Predator spots its prey item, which is maybe a seal. That's has nothing to do with the problem. Just the prey item is all we're concerned about. Now, since we have this variable, can we solve for this that we put in the box? Yes, we can. Okay? So how do we go about finding this variable? What does the equation what does the formula tell you to do? Okay? And you're right, how did you know that? Because our acceleration is right here. That's why we wrote that down. 2.81. Okay. I don't think this problem is, yeah, it'll work out, I think. Okay. Because I just made this problem up just like that. Sometimes the numbers don't come out the way that they should. Now, can we erase all this here? Okay. Because that might be a little confusing for yourselves. Okay. We got a fraction there. What is the best thing that you can do for yourself next? Let's get rid of our fraction. And you do that by putting it over 1. Okay? So once you do that, we're not changing the value of this number. Okay? So what is 1 times 9.52? Okay? Okay? What is 1 times a negative VI? Negative VI. Okay? So we cross multiplied here. What do we do with these two problems? Those two numbers. You're going to do the same thing. So equals whatever 2.88 times 2.81. Okay. We've got a nice linear equation now. So how do we get what's on the left-hand side? How do we get this all by itself? Or do you think, should we add this to this side? Should we add a VI to both sides? No, I would agree. I wouldn't either. Okay? Because you're not making any headway. So back to our original question. How would we get this all by itself on the left side? Why are you right? Because you're right. You know, how many golfers do we have in here? I mean, just think. Here you have this nice long 20-foot putt, and you set it just perfectly. And right after you set it, the ball dropped right in the cup. Because you're right. But why are you right? What type of value is this 9.52? It's a positive. How do you undo a positive value? You have to subtract it. Okay? So if we subtract this side, what do these two numbers do? Now we got 0. So now you could say 0 minus VI equals whatever on the left side. But if you took 9.52 from this side, what about the right side? You got to do the same thing. you've got to do the same thing. So minus 9.52. Negative 1.42, you said? Okay. So what is taking VI from 0? What does that give you? Still gives you 0. So we can go ahead and get rid of this. And we were just going to say we can't have negative velocities. You can have negative accelerations, but you can't have negative velocity. So how would we go about making this a positive value? Yeah, there's two things. You can just look at it. Since we got negatives on both sides, they become positive. And if you needed to illustrate that, you could do that one of two ways. Take the whole thing times -1, and then that will make it positive. Because in algebra, when you multiply two negative values, they become what? Okay? Have you done that in your algebra class? Holy cow, we're already so far ahead in algebra now. Isn't math great? See, one of these times, I'm afraid I'm going to put an E in there instead of an A, and I'm going to sound silly. Yeah, we don't want to say, is meth great? That would be terrible, because it's not great. But if you were... No. No. It's not meant to be put in the human body. No, it's a logical question, asked and answered. I mean, it's a question you ask, honest question, honest answer. No. Okay. So one of the things that we want you to be critical thinkers and have a good work ethic, because we don't. It's better to be a thinker rather than what?
A cheater.
No. Well, that too.
A drinker. A smoker.
No.
A
No.
drugger.
We said it once in here. I'm just seeing if anybody remembers. It's better to be a thinker rather than starts with an S.
Thinker. It's not cheater.
Sucker.
No.
Thinker.
Stinker. Is that what you said?
Yep.
You did not. Yeah, it's better to be a thinker rather than a stinker. You will probably encounter a problem like that. Okay? But the key to this is we are going over how to solve them. Okay? Now, trust me, some of your older brothers or sisters, some of you are maybe the oldest in your family, but some of you, they have gone through these same growing pains. What that means is this is nothing new that we're putting new material on your shoulders. They have solved problems similar to this as well. Okay? So it's all part of responsibility and growing up. Can we erase this? So what is your answer then? 1.43 meters per second. That's correct. So we can erase that. Okay? Well, I guess it's not that we needed to erase it. We still have the content here. Okay. How about this problem? Can we just erase this whole thing? Is that okay? All right.
Oh, okay, Layla.
What'd you say? You couldn't hear my screen.
Okay. The bottom problem. Someone read it, please.
I will.
What is the momentum of one tiny pencil Jenna when her fist begins moving at 1.55 meters per second? The time frame takes 0.72 seconds. The size of 4.25 kilograms and is moving at 17
Okay. So, and maybe to help us out, what is the question ultimately asking? It's asking for this. So, what two things do we need to know to solve for any momentum? You need a mass and a velocity. Well, we have a mass and we have a velocity here, but we'll clarify that in just a moment. Okay, so what do we know in this problem? Mass equals 4.25 what? Kilograms. Okay? Time is 0. What'd you say, 26?
72.
Okay, 72 seconds. Okay, what else do we know?
Acceleration is 17 meters squared.
I heard something about velocity.
Isn't it 0?
No.
1.55.
Okay, so a velocity is 1.55, but is there anything wrong with that number? Why is that important right there? Good, because that is an initial velocity. So what that means then is when she takes a swing at her classmate for an unknown reason, okay, which this is a pretty big fist, by the way. That's even bigger than mine.
Yes.
Yeah. Pretty big hand, isn't it? But to put it into context, though, she was probably wearing this, though. Decided to take a swing at her with this.
Yes.
Oh, I have those in my house.
Okay? All right. Okay. So with that, why is this a problem? What type of velocity do we need to know to solve for? We need a final velocity to solve for momentum. We don't have a final velocity. Can we find a final velocity? Yes. Okay, so what we need to do is find the final velocity we don't know, and what else don't we know? Okay, so this is why writing this content out is vital for solving these problems. Okay? So now what you can do is take this content here. Now you can look at your formula sheet, and what do you think your formula sheet is going to tell you? Where do we have the majority of these variables together where you see them within a formula? Right. Because when you look at this, you correctly said this already. We're looking for this variable. We have the mass, but why can't we solve for momentum?
Because we don't have the right one.
Correct. Because we have an initial velocity. We need a final velocity. Okay. So if we're going to get a final velocity, where is the only place that we've talked about final velocities?
Acceleration.
Okay. So what does acceleration equal then with our numbers?
17 equals VF minus 1.55 over 0.72.
Okay. Now, with that, okay, we've got a fraction again. How do we get rid of this fraction? We can, but do we can do that. It's not, if that makes you comfortable doing that, keep doing that. Okay? So, give me an example of where you're going to cross multiply. 1.55. That's right. Okay. So, so some of you, you say that you understand this, but I get the perception that we don't. This is for your benefit. We don't have to keep going. Do we stop? I mean, just give you the rest of this time? I mean, that's fine. Because if my spidey sense is correct, we'll just hand the exam out tomorrow and we're going to say, I have no idea what I'm doing. Is that possible? Yeah, it's possible. But how can we eliminate that? With practice. Now, when we get done with this, then the rest of the time is yours. Okay? But here's the job. We got this job to finish yet. Okay? So how are we going to get rid of this fraction? Okay. So when we do that, give me an example of what it is we're going to cross multiply. Okay, so once you do that, what do we get when we cross multiply those? About 8 or 9 or... No, it's going to be more than...
12.24.
Okay. Okay, so we cross multiply here, and what are we going to get? Now, we need to get that VF all by itself. How do we go about doing that? Add 1.55. And this is probably something that you have done in your algebra class. You just don't have this put to words. But once you get it to this portion, we need to get VF all by itself. So upon doing that, what do? Because you said it, we're going to add. So if we add 1.55 to this side, what happens to those two numbers?
They cancel out.
Yeah, it's going to give us 0. But if we do that to this side of the equation, what should we do to this side? Okay, so our final velocity is what? 13.79. Okay? So now, we don't need all this information now because we solved for that. Are we on the home stretch now? Yes, because we have the mass. We just solved for this velocity. So go ahead and figure out what the momentum is now. So what do we get? $158? Oh, 58. Okay. $58, whatever, point 0.61. Okay, 6162. All right. And then what's the label for that?
Kilograms over, or per meter over.
There we go. So that's why some of these, it's just not one solving for one variable. Sometimes you have to solve for one variable from one equation and then put that back into a separate one. This is certainly an example of that. Okay. Now, is there any problems that we solve for that can be negative? Yes. What can be negative? Acceleration is the only problem that we solve for that you can have a negative value. Now, you might think that some of your velocities are negative, but you would have a negative on both sides of your equation. Okay. Last chance, you have part 1 of, no, let me say this, part A of your part 2 exam tomorrow, part B of your part 2 exam on Thursday. Okay? I think it's important that you actually have time to read through and make just need some clarity for any final questions. Front row, are we on the bus? Back row, are we on the bus? Okay, middle row, are we on the bus? Because a lot of you are putting your thumbs up and nodding your head yes. Okay, so again, you're telling ourselves up here that we understand this. Okay, so if there's nothing else, the rest of the time then is yours.